today is lesson 11.8, Similarity and Transformations. This is going to be your last one. This is our last section for this chapter. So my goal is to have a test with you for sure by Monday. I know that stinks. Then I got to get into a few, I have to get into a few other things. And then, like, I'm going to have to start reviewing with you already on, let's see, 14th and 15th. I'm probably going to start you on Wednesday. 16th and 17th and 18th can be a catch-up day and see how you did and turn in our books and things like that. Okay? So that's coming faster than you think. Coming faster than you think. Okay, not much battery, people. So today, what we're doing is we are going to be given two figures. You're going to be given two shapes. And the shapes are going to be the same shape, but maybe not the same size. Okay? You will need to determine if these are similar by what we've learned in the past. So think of similarity. Do you remember anything about doing this? Proportions, very good. Remember when we had to draw like bell towers and trees and stuff? It's going to be a lot like that. But we don't have to draw anything today. It's all drawn for us. Yeah, proportion, we're going to solve. Yep, yep. So what is going to be happening? We're going to give us a shape just like this, and we're going to tell if it's similar. So first thing, let's just look at this. Let's just look at this. How do I know if something is similar? Let's just, before, not even these two, how do I just know in general if something is similar? Maddie? Set up a proportion. Okay, they divide and they're equal. Yep. But this could be, I mean, they're the same shape, but that doesn't mean they're always similar. They do have to be the same shape, but that doesn't always mean they're going to be similar. Jacqueline? Okay, maybe. Reduce? Yep. Similar qualities. Okay. Now, if I looked at this and I said, give me one way you can tell this is similar, because these two are. What's a way I can tell, Riley? Okay, so 10 is half of 5, and 2 is half of 4. Okay, so that's one way you could say, okay, you can say 10 and 5, I know I'm dividing by 2, but 4 and 2, I know I'm dividing by 2. If I'm doing the same thing, what's happening? Similar. Okay? Here's another way you can do it. You can actually look at these things and set up a proportion. I can do 10 over 4 is equal to, what has to go on the other side of 10 then? 5 over 2. And I can do this. Do you remember this? This was 20, this and this. That was 20. Guess what? Similar. That's another way, yeah. That's another way. Or you could do your division and see if they reduce the same thing. Yep. This one actually would, because 10 and 4 would reduce to 5 over 2. So that would reduce to the same thing. If you want to turn them into decimals, you can figure it out that way and see if they reduce to the same thing. But I think this is honestly easier. Yes. So now it's not going to be like this. They're not going to give it to you like this. How they're going to give it to you is they're going to give it to you on a graph. Okay? But you can figure the sides out very easily. Very easily. All you need to do is do a little counting. If you can count to like 20, oh my gosh, you should be good to go. Okay? So let's figure out if these two things are similar. So first thing I'm going to do is I'm going to count. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And this is 6. This one over here is 4 and 2. Now here's the part you have to be careful of. If you set up a proportion, you have to make sure the corresponding sides are across from each other. What sides here are actually corresponding? Whoa, 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 whoa. Okay. Now, why are 12 and 2 not corresponding? Yeah, here? You know? Why would they not be corresponding? I look at the side lengths, right. What two sides are the longest? Those are going to be the one that correspond. So I'm going to set this up. I have 12 over 6, and what should go on the other side of 12? 4 and 2. Are they similar? Yes. How do you know? I could divide by 3, or I could multiply them and they equal 24. So there's many ways to tell. Whatever Maddie uses and what Carver uses might not be the same thing, as long as they get the right answer. Okay? Here's another one. Let's tell if these two are similar. So this one is 1, 2, 3, 4, 5 by 3, and this is 4 by, I don't know, 1, 2, 3, 4, 5, 6, 7. Now if I look at this, I can already kind of see a little bit. Okay, so let's figure out, so let's do 7 over 4, what corresponds with 7? 5 5 and 3. I get 20 and 21. Similar? No. Okay, I'm going to actually do another one here for you. I'm going to show you some other shapes that they might show you. Yeah, a lot of this. I have some two-story problems for you, but blank page. Paste. All right, let's do some other shapes that you might see. Another shape you might see is this. Okay, now listen. That's a good question. Now I'm going to show you why you don't have to do that. Okay? So, ladies and gentlemen, what you would just do is you would just count your bottom, 4, and then you would take from here as your height. Actually, this should probably be over 1. I probably went too far. Okay? That would be your height. You count 1, 2, 3, 4, 5, and 6. Okay? Same from here to here. That's okay. You can still see if they're similar or not. Even if they might be different sizes, that's okay. This one? This one? That's okay. You're not counting this. You're counting how tall it is. This isn't going to tell you how tall it is. This way? Oh, pretend. Just make sure. Just pretend it goes the whole way. They're going to go the whole way. They're not going to go half. This would be 2, and this would be 3. That is actually similar, believe it or not. Didn't even try that. You knew it. Okay, let me show you another one quickly. So if I have a triangle, another triangle. What is this? 1, 2, 3, 4, 5. And this is 1, 2, 3, 4, 5. And this is 4. And this is 4. Oh my gosh, seriously. Similar? Yeah, they're going to be similar. Because if I line them up, 5 over 5 equals 4 over 4, 20, 20. Or they reduce to 1. Okay, quick, let's just pretend for a second that this is 7 and this is 5. And let's pretend this is 3 and this is 5. Why would some people tell me that this is similar? They both either are subtracting by 2 or adding 2. You see what I mean? Does that mean it's similar, though? When you're adding or subtracting something, that doesn't make it similar. If I would line these up, it would be 7 over 2 is equal to 5 over 3. I have 21, I have 25. Just because you're adding something does not make it similar. Okay? Questions so far? I don't know what you're talking about. 5. I did? I meant 7 over 5. Sorry. Okay, some story problems. So we're going to also kind of do what we did yesterday. Now the reason why is because before we were given 2 shapes and we had to tell if they were similar or not. Now they're going to give us a shape, give us a scale factor, and we have to make the similar shape. Okay? So, for example, triangle ABC, I'm just going to draw ABC, has side lengths that are 12, 16, and 20 feet. It should be, actually it should be DEF, because I can't have 2 C's. There we go. Does that make sense? A, B, C. And then I'm going to create another triangle that's similar. D, E, F. Now I'm going to use my scale factor. What's my scale factor? 0.5. So to do this, I'm going to go back to my original, multiply each side by 0.5, and I just created a similar triangle. So this would be 6, this would be 8, and this would be 10. Does that make sense to you? So you're kind of using what you did yesterday to create a similar triangle by using what scale factor. Now, what if I had a scale factor of 6? What's that triangle going to look like? A lot bigger than what it is, right? A lot bigger than what it is. Yep. If you're dealing with fractions or a small number, something below 1, it's going to be smaller. Something bigger, it's going to be a bigger triangle or whatever. Same thing here. Why don't you try this one by yourself? Sides of a square are 32 inches long each. 32 inches long each. Create a similar triangle by using the given scale factor. Okay, so if I look at my side lengths, what should my new side lengths be after I apply my scale factor? Brian, 8. Each side should be 8 inches. Everybody understand how I got that? Okay. A few other story problems I need to show you. Okay, so let's say you have a picture. Your picture, this is one, there's a few like this on your homework today. Your picture is 8 by 11 inches. Okay? Let's say you want to enlarge it a little bit for a frame by a scale factor of 2. And then you want to take that picture and you actually want to project it on the wall. So you want to enlarge it again by 5 so you can project it on the wall. Now, my question to you is, what's the new dimensions of this picture? Yeah. Well, these are each a dimension. So, like, it looks like this. 8 and 11. So you're going to have 2 dimensions for every single one. Correct. So what you would do is you would take, first we're going to enlarge this by 2. So it would be 16 by 22. Then you're going to enlarge it again. You're going to go back to what the one you were, not this one, by 5. And it would be 80, right? By 110. Yep, that's another way you can do it. Another way, so I just did it in steps. But another way you can do it is you can actually multiply these two things together. So 5 times 2 is 10. And then take 10 and multiply each of those, and you're going to get your new one. If that makes sense. Okay? I'm going to show you one more. When you're talking about a picture and they ask for dimensions, you have to have both of them. You can't just say, oh, it's just 80. You got to have both of the dimensions. Let's say you're on a microscope. On your microscope, anybody looked at a microscope before? Okay, on your microscope, you're looking at something that's 3 millimeters. That's like super small, you guys. That's like, it's like that, a little bit. Okay. Then let's say I want to enlarge it for a test, so you can see it on your test. And I'm going to enlarge it by 10. Just think about it. Millimeters are really small. For you, so you to see it on your paper, I want it to be kind of big. Then I want to enlarge it again, so I can put it on the smartboard by 20. Find what the new figure is going to look like. How big is it going to be on my smartboard? 600. So first I did this times this would be 30, this times this would be 600, 600 millimeters. And let me show you what that looks like. So I went from, down. I went from this big to this big. That's pretty cool, isn't it? You can actually see it. And actually, this makes sense. I would project it that big on a smartboard, so it actually does make sense. So there's 2 story problems like that on your homework today. Everything else is taking stuff off graphs like this and figuring out if they're similar. Okay?